In this video, I'm going to show you how to use GeoGebra to model your water fountain parabola. So first open GeoGebra. You can go to www.geogebra.com, Geogebra, to download that, and then you'll need to log in, and you can do that using Facebook or Google. And then once you have it on your computer, it should look like this, and you will need to take the water fountain parabola photo that you took, the close-up, and you'll need to open it as the background on the program. So to do that, you'll go to Edit, and then Insert Image From File, and choose the photo of your water fountain parabola and say Open. And now you can see that I can't see my Y and my X axis, so I actually want to make this the background. I want to kind of make it a little bit transparent so that you can see the Y and the X axis. So just select it and come back up here to your menu, and I believe it is under Edit Object Properties. And then go to under Color, the Color tab right there, go to Opacity. And on opacity, you want to change this down, make it more grayscale, so to like about maybe a little over 50%. And then close that, and you can see now this is more of a transparent background, and you can actually see your Y and your X axis. The next thing you want to do is you want to move the photo over so that the location where the water is coming out is at the origin, the 0, 0 on the Y, and where the Y and the X axis meet. So you can just pick your photo up and you can move it around, and we want to get it to where, so the origin is supposed to be where the water originates, so about right there. And it doesn't have to be perfect, but that looks pretty good. And now you can see we have this nice parabola. It's starting at the origin, the water's coming out at the origin, it's going up to, about a little under 4 maybe right here, and then around 4 and coming back down. Alright, so now we need to find an equation that models this parabola. And to do that, remember that you know the form for it. You know the general form for the equation of your parabola, which is you're going to have x minus h. It's a y equals x squared parabola, so x minus h squared equals 4p times y minus k. All right? And so you have that, you know that, and you can kind of look at this and remember that h comma k is the vertex. So if we go over here on our parabola, on our photo, and we can look at where the vertex would be, we can see it would be about right here. We know that p is going to be negative because our parabola is opening downward. It's not pointing up, or it's not opening up, it's opening down. So we know it's a y equals x squared, but it's going to be a negative x squared. So that p value right there, we know that's going to end up being negative. If p is negative, then our focus is down here and our directrix is up here. All right, so we know that that's what we're going to anticipate, that p should end up being negative, and that our h comma k, that needs to be the vertex. So let's figure out what that vertex is. Basically what we want to do to find your equation that models this parabola, you want this formula right here, but let's think about what we need to plug in. We need to plug in h and k. We also need to plug in p. And once we've figured out what h and p and k are, then we'll have an equation for the parabola. So let's find the vertex, and you can actually just click up here on point and stick a point right there where the top of it is. Okay, right there at C. And if it's not exactly perfect, you can move it around with your arrows. I'm going to say it looks like it's at about right there. That's my vertex. Alright, so I stuck C there, and notice the coordinates are right over here on the left-hand side. It says that C is at negative 3, 3.9. Okay, so the coordinates of my vertex, vertex is at negative 3, 3.9. Alright, so I'm going to plug that into my formula for the parabola. So then I'm going to have h minus the x value, which is negative 3, so that's going to end up being x plus 3, quantity squared, equals 4p times y minus k, and k is 3.9, so I'm going to have y minus 3.9, like that. So I'm close, I just need that p value now. And to find p, you can either play around with this and try to find a value that works using function transformations, or you could just get another point on here, which is what I think would be the easiest way to do it. So get another point. Now we already said that it's going to go through 0, 0, so that would be probably your easiest point to choose. You could also choose a point over here. It looks like it goes through staying kind of on the outside of the water. Right there, it looks like it goes through about -6, 0. So we could use either of those, okay, to model. And either one of those, we should get about the same equation for our parabola. So what I'm going to do is I'm going to plug one of those points in, the coordinates of one of those points. That point right there is at 0, 0, and I can plug the coordinates of that in for my x and my y, and then I can solve for p. Okay, so let's try that. I'll go ahead and put 0, 0, 0 is the easiest one, so let's do that one. That's going to give us 3 squared equals 4p, just putting a 0 in for x, because I know that this parabola goes through 0, 0. So 3 squared equals 4p times, 4p times, y is also 0, so this is just going to be a -3.9 in here. Alright, so 3 squared gives me 9 equals 4p times 3.9, and you can just get a calculator out. So that comes out to -15.6 p, 4 times -3.9 p, and then to solve for p, I'm just going to divide both sides by the -15.6. Okay, and use your calculator again, and that gives you 9 divided by 15.6 is -0.5769, so p is then equal to -0.5769. I'm going to go ahead and take it out to those 4 decimals so I get a better accurate model for my parabola. Okay, so then go back up here, and I'm just going to erase right here, and we're going to take this formula that we came up with, the x minus 3 quantity squared equals 4p times y minus 3.9, and we're just going to plug our p value in that we found. So I get x plus 3 quantity squared equals 4 times p. Let's just go ahead and multiply that p value by 4, so times 4. Alright, and that's going to give me 2.3077. Okay, 2.3077, and then I have times y minus 3.9 right here. Alright, and that is my equation for my parabola in vertex form. Right there. And now to check it, we want to plug it in, and if you go down to the bottom of your GeoGebra screen, you should actually see, let's see if I can bring this up. Okay, so you should actually see a place where you can see input at the bottom right there, and that's actually going to let you put in, that's like your y equals, and on your graphing calculator, and that's where you would input your function. So I can actually put, the nice thing about GeoGebra is I can actually put this in as it is. I don't have to solve it for y. So I'm going to do x plus 3 quantity, that whole thing is squared, equals 2. And that was a negative. I should have remembered my p value is negative. I should have had a negative on here. Okay, and I knew that because I knew it had to be pointing down. So that should be x plus 3 quantity squared equals -2.3077 times y minus 3.9. And let's graph it, and you can see it beautifully models our water fountain right here. The parabola starts here, goes up, goes right through our vertex, comes back down, and goes right through our other point that we chose. So you can see that no matter which of those points, if you had chosen E or chosen point D, either of those, and we could go through the calculations if we chose -6, 0, but they should give us about that same value for p, and we get that same model. Okay, so then this is the screen that you need to take, and you need to print this and include it on your poster. So to print this, what you'll do is come up here, and you can say File, Export right here, and then Graphics View as a picture right here. And when you do that, it'll just do it as a PNG. Alright, and you can do this and say what you want it as. A PNG is fine. And then say save. Okay, and I'll ask you where you want to save it. I'll just stick it on my desktop, and I'm going to call this, so I don't save over my other one, I'm going to call it Parabola 2 and save. And now I should, if I go to my desktop, let's see, I should be able to see it right here. Alright, and yes. I don't know if you can still see that in the video, but it actually came up very nicely. Alright, so that's it. That's how you use GeoGebra to get your graph. And don't forget to actually go back over to this function right here. You have this is in vertex form. The x plus 3 quantity squared equals -2.3077 times y minus 3.9. That's vertex form, so you need to actually simplify that to get it in standard form. And to simplify it, remember standard form is the ax squared plus bx plus c form. And to get it in that form right there, you just need to multiply this x plus 3 quantity squared out, multiply the -2.3077 times all of this, and just get it into that form. It's supposed to be in y equals ax squared plus bx plus c form. Okay, not y squared, just y. So just multiply that out, do that algebra, and you should be able to get it in that form. Y equals your x squared terms plus your x terms plus your constants. All right.